problems to your module, but I really wanted you to work in MATLAB because that's where your test is going to be. So that's why I didn't post these before now. But I do have some problems that if you wanted to kind of practice by hand, they're in your modules and it's just a PDF file. And that's what I'm going to pull up. But it's a PDF file from MATLAB with the basically a printed copy of the test review problems. So I'm going to pull that up and share that screen with you. Give me just a second, and I hope I'll get that up. So this is kind of what they look like. And I usually, when I go over one of these reviews, I fix the problems where I have room to write. And so on some of these, I'm not going to have enough room. So I'm going to have to go off of this and come back to a different screen. But this is some review problems, and they're not in any particular order. But you can see, I think, if you can't, I'll tell you what section they come from. So before that, I hate to say, but I'm going to have to monitor the test because if I don't, I mean, some people couldn't do the honor lock for the practice problems for whatever reason. And I'm going to try to help those students after class today the best I can. But I have to use the honor lock for the final exam. That's really the only choice that I have. I used to be able to use Lockdown Browser, but some people can't use that. And I noticed on some of my Lockdown Browser tests, some of the problems are not loading properly. So that's why the college basically is going to be switching to honor lock, and hopefully it's going to be much easier to use once you, I guess, get used to the process. Some people do real well with it, and I think it has to do with the settings on your computer and how you have your settings set up for your tabs. So I don't know if you can see my screen right now, but I can open more than one tab at the same time, and I can put more than one tab on my screen. So if you are looking at my computer screen right here, if you see this little up in the top right corner, there's an X, and then there's the little two boxes, and then there's a dash. Well, sometimes I have to use those two boxes right there to make it to where I can see more than one screen at a time. So what I have to do is make one of them smaller and then just sort of grab it up here along the top, and you can kind of move it around. So when your honor lock, somebody's honor lock screen, they said when they start screen sharing, their honor lock thing goes away. But it shouldn't go away. It should be up on your screen. So I don't know if you could look down at the bottom and look at the icons, like if you can see the bottom of my screen where I'm moving around. I don't know if you can see that or not, but at the bottom of your screen, you should be able to have some, either on the bottom or the side, should show you what tabs are open. All right, so what we're going to do then after the class is I'm going to go in through my student account, and I'm going to try to go through the process with you the best I can. Okay, I know y'all are saying it's going away, and it probably is going away, but what's happening is when you click screen share, it's probably going behind it's going behind there. So what you're going to do is use this little box that's in the top of your screen, the little two boxes, and you're going to click on that and see if you can see what's behind there, because it's not really going away. It's just going behind the screen that you're sharing. So we've got to figure out how to get it in front of the screen that you're sharing. And you're going to have to use these little two boxes here, I think, to do that. Okay. We're going to try that anyway after this class. But for now, I want to go through a few of these problems. Do any of you know of some particular problems that you've had trouble with if you went in and actually did the practice problems? Is anyone having a struggle with any certain section of problems? So we're testing on 8.1, 8.3, 8.5, 8.4, and 11, 11.5, I think. No, HonorLock doesn't have trouble with Chrome. You have to use Chrome. So it shouldn't be having any trouble with Chrome, because HonorLock you have to be in Chrome in order to use HonorLock. So HonorLock should have no trouble at all with Chrome. Chrome is what you have to be in. So if you're not in Chrome, you're not going to be able to use HonorLock at all. All right, so did y'all want me to go over some particular ones of these problems? Do you want me to just, I tell you what I'll do. I'm going to scroll through these and tell you what section it comes from, and you tell me if you want me to work it. So I have to change screens for just a minute. I see somebody's typing, so let me wait and see what they're trying to say. All right, I'll work the first one. Hopefully, I can find my pen. Okay, so this problem, it says this is solve a system. This actually is in 8.3. And you're going to take the second equation and write that base as a 3. So what we know is 3 squared is 9. So we're going to rewrite it so that we have the same base. If we can get the same base, then we can just eliminate the base by the one-to-one property. So I'm going to work with this one right now. So y equals 9 to the negative x. So 9 can be written as 3 squared. So what we get is 3 to the negative 2x. So now my two equations are 3 to the 5x plus 1 and 3 to the negative 2x. So I can replace one of these y's with the other one. So basically y equals 3 to the 5x plus 1. I'm going to substitute that in for y. So I can put those two equal to each other. And then using the one-to-one property, I can drop the bases, because now my bases are exactly the same. Now I can only do that if the bases are the same. All right, so I have 5x plus 1 equals negative 2x. So I'm going to subtract 5x and get it over here with my 2x. So then x is negative 1/7. So I know what x is, and I need to know what y is. So I either want to plug into the y equals 3 to the 5x plus 1, or I want to plug into y equals 3 to the negative 2x, because see, this one, 3 to the negative 2x is more simplified than 9 to the negative x. So that's the one I'm going to plug into to get y. Now, if you plugged into this one, y equals 9 to the negative x, and you put that answer in there, and let's say MATLAB counted you wrong, well, I would go back in and count it right if you didn't have it all the way simplified. So I'm going to plug into this one, 3 to the negative 2 times negative 1/7. That's where I have to plug in x. So y is going to be 3 to the 2/7. So negative 1/7 as an ordered pair and 3 to the 2/7. Now, again, if you plug that negative 1/7 into the 9 and you got 9 to the positive 1/7, I would give you credit for that. It's not simplified, but I would still give you credit. Questions on that one? I'm not sure what that x cubed plus 2 to the 4th, what does that mean?
I think it's in the last section, but it's supposed to be x to the third power plus 2 in parentheses, and then it has the 4 on the outside.
Okay, so what does the question say though?
Oh, I want you to work that. Whenever you come to a problem like that, I want it to be can you work that for me?
Oh, okay. I'll be glad to. I just don't like, I see the problem, but I don't. Oh, you mean, I know what you mean. You mean the binomial theorem problem.
Yes. Uh-huh.
Okay. Okay. Yes, I will find one like that. In fact, I think on my page, I think that looks like number 7, actually. It looks almost exactly like number 7 on my page. So I will do that. Now let me scroll through here and you can look at these problems and see if you see any before we get to number 7 that you want me to work. Any of you just look at the problem. So this is number 2. That's graphing 2 lines and finding the intersection. This one is graphing 1 line and shading. This one is just solving by substitution. This one is a partial fraction decomposition. Number 5. So if you see one you want me to work, type that number in the chat bar. I can't see it right now, but I will look in just a minute. And then number 6, that's graphing. It's going to be graphing 2 lines and shading the region where they intersect. So that's going to be number 6. And then number 7 is a binomial theorem. That's the one she asked about. So I'm going to do that one. And I will do any before that if you tell me you need one. So looking back at the problems, number 6, 5, 6 is the inequalities, graphing 2 lines and shading. 5 is the partial fraction. 4 is the system by substitution. 3 is the graphing just a single inequality. And then 2 is solving by graphing. So you guys type in the chat bar if you see one that you want me to do. Okay, so far I see 4, 5, and 6 that y'all want me to do. Okay, so we're going to go to number 4. So in order to solve by substitution, I don't see any squared terms. So these are linear. So all you're going to do is either solve for X or Y, whichever one is easier, and substitute into the other equation. So if I'm looking at this first one looks easier to solve for Y because all I have to do is add 6X to both sides. So that gives me Y equals 6X plus 11. Now, I know what Y equals, so what I'm going to do is substitute that. It won't let me show, but I need to substitute it. I don't know why it won't let me do that correctly, but I need to substitute, well, I can't use my underline, but I need to substitute the Y equals 6. I need to substitute 6X plus 11 into the Y right here. So I'm going to put that in place of Y. So 6X plus 6 equals 6X plus 6. Because I got to distribute there. And I have to subtract. So if I subtract 6X, that's going to give me 6 equals 6. And since that's true, 6 equals 6, that means that any solution is going to work. So an infinite number of solutions works. And what you might not know is that MATLAB wants you to actually write the equation that satisfies the, so if you put where you solve for Y right here, right there, that's what they want you to put. This really means everything on that line. Infinite number of solutions on that line. So that's what you put there. It's just solve, make sure you have solved for Y and then put that, that's what you put. So this is the answer. And that is a dependent because that graphs the same line. If you get infinite number of solutions, then both of those equations actually graph the same line. So any questions on number 4? Okay, to do number 5, I'm going to need to open another window and share with you because I don't have enough room to work it, but I will. Well, let me just do number 6 and then I will come back and do number 5 because I need to do that on a different page. So if I want to sketch these, what I'm going to do first is I'm going to sketch them as an equation, but I'm going to use dashed lines because both of them have inequalities because no equal sign is there, but I'm going to figure out what to graph by the equations. So I'm just using the y-intercept. So 0, -3 is the y-intercept. This is slope-intercept form. And the slope is 1. So I would put 1/1. So I'm going to go ahead and graph that line. Let me put it in the right place. So I'm going to graph it at 0, -3. For X and a 0 for Y. And I get 0 is greater than -3. And that is true. So I want to shade the same side of the line as the test point. So I'm working on the blue. So that's why I did all that in blue. So my test point was right here. So that means that I'm shading. Let me see if I can use this highlighter here to shade. I don't know if I can or not. So I'm trying to shade, but it's letting me not do that. I don't know what's wrong with the shader. So I'll just do it this way. And now I need to test a point for the red line. So Y is less than -X minus 1. So you have to go back to your, so I'm going to test 0, 0 again, but you have to go back to the inequality. So this says 0 is less than -1. That is false. That is not true. So I want to shade the other side of the line, the other side of the red line. So here's the test point. So that means I want to shade this side. So if I use a different color, all of this in this part is where they intersect. So that would be the part that you would use the paint bucket on in the test. So on the test, in MATLAB, you would use the paint bucket to shade that section of the graph. Okay, so for just a minute, I'm going to stop sharing my screen. And I'm going to put a whiteboard up. And this is Number 5. So I'm going to do a partial fraction decomposition here. So I know this is going to separate into A over x plus 9 plus B over x plus 7. So I know it's going to separate into that. So I'm going to multiply everything in the, oh, that's going to be a, never mind. It's not going to work. I have to use a. Okay, so I'm going to multiply everything in the equation by the least common denominator, which is x plus 9, x plus 7. So both sides I need to multiply by x plus 9, x plus 7. X plus 9, x plus 7. X plus 9, x plus 7. That's the least common denominator. Over here, both of those will cancel out, so I end up with 7x plus 53 equals. Over here, I have A and x plus 7 left. A times x plus 7. And here, I have B times x plus 9 left. So now I want to let my x be something that's going to cancel out one of, in other words, I want to pick a number that's going to, the A term or the B term go to 0. So if I look at this one, what would make the A term go to 0? -7 plus 7. So I want to let x equal -7 first. So I'm going to put -7 in for x. So this is -49 plus 53. So that's going to give me 4. This one's going to 0, and -7 plus 9 is 2b. So if I divide by 2, b equals 2. So now I know that b is 2. All right, now I'm going to let x equal -9 so I can make the b term. So I'm back to this equation, and I'm going to let x equals -9, and I'm going to use -9 so the b term goes to 0. So I'm plugging in -9. So now this one goes to 0. So -63 plus, that's -10. going to be negative 2a. So if I divide by negative 2, I get a equals 5. So a is 5 and b is 2. And you can just plug those into MATLAB for that answer. I think they want you to probably type the whole thing in. 5 over x plus 9 plus 2 over x plus 7. All right, does everybody have that, or do I need to wait for just a minute before I clear that off and share my screen again? To me, those are the easy problems to do. Okay, so this was A. And A was 5. And 2 over x plus 7. All right, this one was one that someone wanted me to work. So what I know in this one is I know n is 4. And I know that a is x cubed, and I know that b is 4. So each time I'm going to plug in, I'm going to actually start with the exponents. So remember we're, let me see how I want to say this. So let me write this. If I had, trying to find somewhere else to write. I'm going to use the space down here in just a minute. But if I had a plus b to the n, remember I started with n 0, a to the n, b to the 0. And then plus n 1, a to the n minus 1, b to the 1. Plus n2, a to the n minus 2, b to the 2. Remember the pattern? The exponent on A starts at n and goes down 1 every time. The exponent on B starts at 0 and goes up 1 every time. So up here, I know n is 4, A is x to the 3rd, and B is 4. So I'm going to start my combination of 4, 0, and then I'm going to do x to the 3rd raised to the 4th power, 4 raised to the 0 power. Then I'm going to go 4, 1, x to the 3rd. Now I'm going to go down by 1, so that's going to be 3. And then 4, I'm going to go up 1, that's going to be to the 1st power. And then 4, 2, x to the third, that's going to be to the second power because I'm going down 1. 4 to the second power because I'm going up 1. 4, 3. This is the combination. Remember the N combination R thing on your calculator that you use? That's what you can use for that. Or you can use Pascal's triangle. Then we have 4, 3. We have x to the third, down 1 to the first power, 4 up 1 to the third power. The exponents decrease by 1 on the first term, increase by 1 on the second term. And then I have 4, 4, combination 4, x to the third to the 0 power, 4 to the fourth power. So anytime you got a 0 power, that's 1. But I put the zeros in there because the pattern's easier to see. So this just keeps going out to where you get to 4. Now, I'm going to erase that because I'm going to do some simplifying down there. Before I actually simplify, so you know I was using this pattern here. So this was the binomial theorem. All right, so 4 combination 0 is 1 times x to the 12th times 1. So that first term is just x to the 12th. All right, 4 combination 1, you can do that on your calculator. Hopefully you have a calculator or you can use that formula for figuring out the combination. So 4 combination 1 is actually 4 times x to the 9th times 4. That's 4 to the first. I'm just simplifying now. So that's going to be 4 times 4 is 16 x to the 9th. And you really have to work this out. You can't just guess what those exponents are going to be. You really have to work it out. Power to a power, you multiply. Now, 4 combination 2 is 6 x to the 6th. 4 squared is 16. So that's 96 x to the 6th. 4 combination 3 is 4 x to the third, and then 4 to the third power is 64. 4 times 4 times 4. So 4 times 64 is 256 x to the third. And then 4 combination 4 is 1. X to the 0 is 1. X to the third to the 0. Anything to the 0 power is 1. And then 4 to the fourth power is 256. And that's your answer for that one. So it's just a pattern and just seeing the pattern. Define your N, your A, and your B, and then just work it as a pattern. Questions on that one? All right, well, let's move along. So I'm letting you look at the problems as I go. So I'm I'm easing through the next few problems, and you tell me. Number 8 is solving the system by addition or elimination. Some people call it elimination. Number 9, same thing. 10, that's another partial fraction. The only difference in number 10 is you have to factor that denominator. So that's going to be x plus 7 and x plus 2, because you got to multiply to get 14 and add to get 9. So 7 and 2 are the only things that's going to do that. So then you would figure out your A and your B. Now, what order you put those in doesn't matter, because your A and your B is going to take care of itself regardless of which way you write them. It's going to be a certain number over that first term and a certain number over that second term, and it will work itself out regardless. Okay. All right, so I'm scrolling through again, and I'm looking at number 11. That's sketching a linear inequality of an absolute value problem. So you got to graph the absolute value and then do your inequality. That's a circle inequality. And I'll stop right there. So let me go back through them again. So number 12 is a circle inequality. 11 is an absolute value inequality. 10 was a partial fraction again. I'd like to not do another one of those if I cannot. 9 is system by addition. 8 is system by addition. So I just need you to type in which ones you would like to see. I see 2 11s. I see 2 11s, so yes, I'll do 11. Anybody have any other ones in that set that you want me to do? Okay, I'm going to go back and look at 11 then. All right, do you remember y equals absolute value of x? The easiest way to graph this is to know what your parent graph is and then move it, move the points. Do y'all remember doing it that way? It's so much easier to do it that way. Either way, you've got to figure out how to graph it. Okay, so if you use those ordered pairs, you would have an absolute value that just started at the origin and made a V. Well, this one is y equals absolute value of x minus 8. So remember, if you were doing this one back in the transformations, and you should always use the transformations. That's why we used them. That's why we learned them. This is shifted to the right 8. So I would just add 8 to all of my x values and get those ordered pairs. And actually on MATLAB, you're probably not going to need but 3 points. So you're going to need your vertex and you're going to need your 3 points, but the vertex is always going to be the 0, 0 shift. So your ordered pairs is 6, 2, 7, 1, 8, 0, and then 8, 1, and 10, 2. So if I go to the left 6 and up 2, and then 7, 1, and then 8, 0. So you're going to have to give this point the vertex and then one more point over here. So it's going to ask you for 3 points. So probably these are the 3 points you would want to put on there. And it's dashed because this is an inequality without an equal. So we would want to just dash that. MATLAB's going to draw this for you once you get those 3 points, and you're going to choose the dashed line. And now I'm going to test a point not on the line, and I can test 0, 0. So I'm going to test that point right there because it's not on the absolute value. So y is less than 0 is less than absolute value of 0 minus 8. 0 is less than or equal to the absolute value of negative 8, but absolute value makes that positive. So 0 is less than 8. That's true. So that means if that's true, then I'm shading the outside part or the part that's on, like I've either got to shade inside the V or outside the V. Well, the test point was true out here. So that means that I'm shading outside. So my paint bucket would shade on the outside of this absolute value. But the only way you can get this problem to work is you're either going to use the transformation because you have to know where the vertex is. So I can tell you how to find the vertex. Right here, it's going to be whatever you plug in here that makes that 0. 8. That's where you're going to start. But if you'll do your transformation table, it'll do it for you. Either that or you're going to have to pick a lot of points to get that V because you're going to have to get a V before MATLAB will let you complete the problem.
Miss Rachel,
Yes.
the 8 plus 1 was supposed to be 9. It's 7, 1, 8, 0, and 9, 1. And then also somebody asked about why did you do the 8 to the, I guess add the 8 to the X.
Because of that, because that's the transformation. Okay. So I did do that wrong. I did do the 9, 1 wrong. That should have been a 9, but that's what I graphed. I actually graphed 9, 1. I just wrote. And why did I go to negative 8? That's another question.
Yeah.
Did y'all ask me that question too? Why did I go to negative 8, 0? I don't know why I did that. Guess I was talking. I should shut up and do my work instead of talking so much. So I said right 8, but I went left 8. I should have gone over here. These were my points. I'm sorry. I am so sorry. Y'all are used to me mucking up like that, aren't you? I did say muck. So making a mess of it is what I mean. So I did mess that up, and everything else is going to still stay the same though, because it's still going to be true. So I'm still going to shade outside of the V. And why did I add 8 to the X values? Because this is a transformation that shifts the graph to the right 8. So this is the parent. Y equals absolute value of X. Back in 2.3, we learned about what we call transformations. Do y'all remember anything about that? You're not supposed to forget all this stuff. You do have a final exam coming up. In 2.3, we learned about transformations, and anything that was inside of the function with x was a shift in the opposite direction. So since this was a -8 inside of the x, inside of the absolute value, that meant we shifted right 8. So you might want to go back and review your transformations for some of these because you might have to use them. But that's why I moved everything to the right. Now, because I messed up, I moved everything to the left, but it was supposed to be to the right. That's why I added 8. If it had been a +8, I would have subtracted 8 and moved everything over the other direction. Does that make sense now? I think what didn't make sense was I put the graph on the wrong act. I put the graph left instead of right. Thank you for cutting in on me and telling me because I need you to do that. I can't see the comments. So when I'm actually working on the work page, I can't see the comments. So anytime I mess up like that, go ahead and break in so I can fix it real quick. I see y'all were asking the correct questions, though. I just couldn't see them. All right, so that was number 11, even though I messed it up pretty good. Do y'all need me to do the circle one, the number 12? Or y'all got that one? Did y'all need me to do this one? I'll try not to mess it up if you need me to. Okay, I think somebody said yes. This one's really easy. This is a circle because of the x squared, y squared. And because you should know it's a circle because it's x squared plus y squared. The center is at 0, 0 because there's not an h and a k. And the radius squared is 9. Remember, our circle looks like this: x minus h squared plus y minus k squared equals r squared. So the radius is 3. And since this has an equal sign, I'll draw my center and go out. I need to go up 3, to the right 3, to the left 3, and down 3, and then just draw the circle. And then test the point, do a test point that's not on the circle. So any point that's not on the actual outside of the circle, you can test. So I can test 0, 0. So that'll be 0 squared plus 0 squared is greater than or equal to 9. So I'm just plugging into the function. So 0 is greater than or equal to 9. That's false. So since that's false, then I know I'm going to shade not on the inside, but on the outside of the circle. So you would use your paint bucket on the outside of the circle for that one. Anyone need me to leave that one up longer, or you got it? Okay. So I actually wrote on the wrong screen, so I need to erase this and go back to my other screen. another binomial expansion. So remember, you have a plus b to the n. So that's going to be n0, a to the n, b to the 0. I'm going to go ahead and write it all the way out to 3 this time. So a to the n minus 1, b to the 1. So the n is 3. So I won't keep going, but you see the n is 3. So for this one, you're going to have 3, 0, and then you're going to have 3x, which is a to the n, which is 3, and then you're going to have negative y to the 5th to the 0 power. Okay, so I start with the a term, which is 3x to the n, which is 3, and the b term, which is negative y to the 5th, raised to the 0 power. Now I'm going to go to the next one. It's going to be 3, 1 combination. 3x, go down 1, so that's going to be 2. And then negative y to the 5th, that's going to go up 1, so that's going to be to the 1st power. Plus 3, 2, 3x to the 1st power, negative y to the 5th to the 2nd power. Plus, now the last term is 3, 3, so it should be the first term should be to the 0 power, and the second term should be to the n power, which is 3. So it's a pattern, and you got to be able to see the pattern. Okay, so this is going to be 1 times 3 to the 3rd is 27x to the 3rd, and anything to the 0 power is 1. So the first term is going to be 27x to the 3rd. Well, the good thing about it is that knocks those two out already. So it's got to be B or D. All right, let's see what the second term is. 3 taken one at a time should be 3. Times 3 squared is 9x squared. And then negative y to the 5th to the 1st power is times negative y to the 5th. So this term's going to be negative. So I'm going to have minus 27x squared y to the 5th. Because of that negative right there, that's going to turn that plus right there into a minus. Make sure y'all understand that part. So 3, 2 at a time is also 3 times 3x to the 1st power is 3x. And then negative y to the 5th squared is positive y to the 10th, because negative squared makes it positive. So that will be plus 9x to the 1st, y to the 10th. And it asks just for the first 3 terms, so I actually don't need to go on any further. So now I know that I'm confused. What's the difference in B and D? Oh, that one's got a positive right there. I see. I thought they were the same for a minute, but then I saw the positive on the B term, so that's what makes that one wrong. So just ask for the first three terms so I don't really have to finish that. All right, so let's go back and look at, I didn't go through, we did 12, 13, that's just two circles. So you're probably going to end up shading in between the circles on that one, I believe. You'll have two circles with a different radius. One's greater than, one's less than. So they're going to end up being shading in between the circles. That one, you just need to pick out the solution. The solution is right there where they intersect. So that's going to be 2, 4. You don't really even have to do anything. Just look at the graph. Okay, this would be 16 would be solving this equation by addition. This one, I would solve this one by substitution probably. Solve it algebraically, and then you could graph it and see, graph these on the same thing. So that's 17, 18, solving, that's 2 lines. You're going to graph and find the intersection. 19, that's a system of equations. It's just linear. You're just going to use your property or addition or elimination to solve. And then let's look at 20. That's using substitution, and you already have X in the form where you can substitute it into there and solve. All right, so now let's go back through here. So 16 through 20, do y'all need me to work any of those 16 through 20? Yes, I can do, you're very welcome. I can do 17. And 18. Okay, so if I wanted to solve this algebraically, I guess I would just take the 2x and substitute it into the y. So that would give me x squared plus 2x in place of y squared equals 36. So that's going to give me x squared plus 4x squared equals 36. I'm just trying to double check myself and make sure. So x squared plus 4x squared is 5x squared equals 36. If you divide by 5, you get x squared equals 36 over 5. So x is going to be plus or minus the square root of 36 over 5. So that's going to be plus or minus 6 over the square root of 5. Or if I rationalize that, multiply by the square root of 5 over the square root of 5, that's going to be plus or minus 6 square root of 5 over 5. So y is going to be 2 times 6 square root of 5 over 5, which is going to be 12 square root of 5 over 5. And it's also going to be 2 times negative 6 square root of 5 over 5. So y is going to be negative 12 square root of 5 over 5. So you're going to have two solution sets. So you're going to have x is 6 square root of 5 over 5, 12 square root of 5 over 5, 6 square root of 5 over 5, negative 12 square root of 5 over 5. Now, I want to make sure and check my answer on this one because that one is pretty weird. Just want to make sure it's the correct answer. Yep. I thought that I had done it correctly, so. Okay, so those are the two ordered pairs for the solution. And then it just wanted you to graph them. So to graph the circle, the center's at 0, 0. And the radius is 6. So this would be my circle. Best I can draw. I'm not real good at this drawing circles on here. And then y equals 2x plus 0. The y-intercept would be 0, 0, and the slope would be 2. So 2 over 1. And then you would have to go down to also to get the whole line. You wouldn't have to do this in MATLAB because it would do the line for you once you plotted 2 points. And see, those are your intersection points, which are these weird numbers right here, these irrational numbers. And you can see they don't cross at an even numbered point. So in case you needed to have time to write this down, I'm going to wait until you let me know if you need to see any more of that or you need to ask any questions on that. This one, the second one, thank you. Yeah, the second one should have been plus or minus 6 square root of 5 over 5. It should have been, because when I plugged in the negative, I got the negative. So this should have been the negative. Sorry. Thanks. All right, and then somebody had asked for 18. All right, so I'm going to just, if I just use the X and Y intercepts for this one, it would be easier to graph it. Or I can solve for Y, it doesn't matter. This one would give me Y equals negative X plus 8. So my Y-intercept would be 0, 8, and my slope would be negative 1. And then this one, when I solve for Y, it would be Y equals X plus 4. No, minus 4. I'm not doing the algebra here, so I hope that's okay. But what I would do is move the Y over here and the 4, or if I move the X over, then I've got to divide by negative 1. So if I solve this for Y, that gives me x minus 4. So my y-intercept would be 0, negative 4, and my slope would be 1, so 1 over 1. So you could use x and y-intercepts on here too. It wouldn't matter. 0, 8 is my y-intercept for the first one, and I would go down 1 to the right 1. And again, once you do a couple of points, MATLAB's going to graph that for you. And then the second one, my y-intercept is 0, negative 4, and my slope is positive 1. I'm just doing these points so I can come up, see where they intersect. But again, the good part about MATLAB is if you can get 2 points, then it'll graph it for you. So right there is your solution right here. So 6, 2. So let's scroll down through here and make sure that there are no problems that I haven't at least talked about. This one's by addition. This one's by substitution. Addition again. This one is, let me work this one real quick because y'all always seem to get confused on these easy problems. But if y equals x, then I would take this x and put it right there for y. So that would give me x equals 5x squared. And then I would subtract x from both sides because this is a quadratic and I can't use the square root property because I have an x term. But I can factor out the GCF. And then I can solve those factors. So x equals 0 is one solution. Add 1 to both sides, and I get 5x equals 1. X equals 1/5. So if I plug x equals 0 right here, I get y equals 0. So one of my answers is 0, 0. Then if I plug in 1/5 for x here, I get y equals 1/5. So my other answer is 1/5, 1/5. To graph y equals x, that means I have a y-intercept of 0, 0 and a slope of 1. And if I graph y equals 5x squared, I would just make a table and get a couple of points because you only need 2 points really, or 3 points. So if I plug in 0, I get 0. So I do know that's one of my answers. Then if I plug in 1, I get 5. So 1/5, so that means negative 1/5 is also a solution. Have to have 1 on both sides. So if so when MATLAB draws this, it's going to look like that, but it's actually going to intersect way down here. So it's going to be more, it's going to be closer down here where it intersects. Okay, so I'm really out of time, but I really think that I have done some of each type of problem. I haven't done one of these, but that's all I have left is really just doing maybe one of these. I can give you the two equations you would need to solve if you want me to do that real quick. So it says a city zoo has different admission prices for adults and children. So you got 3 adults and 2 children. They're going to go to the zoo for $79.57. And then this one has 2 adults plus 3 children, and they're going to go for $74.98. So you're just going to use, I would use elimination, probably. So I would probably multiply this one by 2 and this one by maybe, or maybe this one by -2 and this one by 3. That would eliminate the adults, and you could solve for the children and then plug back in. So those are the 2 equations you would solve for that one. And then I'm going to go down to this one. A collection of dimes plus nickels equals $4. Let's see. Well, let me do this one first. Dimes plus nickels, there's a total of 60. So 60 coins, dimes plus nickels equals 60. And then the dimes are worth 10 cents. So 10 cents worth of dimes and nickels are worth 5 cents. So 5 cents times however many nickels and dimes you have is going to equal to the $4.65. So that's the 2 equations that you would solve. And I would definitely multiply by 100 and just get rid of those decimals on that second one before I worked it out. So first I would multiply this by 100. Well, yeah, I probably would. So that would give me 10 dimes, 10D plus 5N equals 465. That's the 2 equations I would use. And then you won't have to worry about decimals. So then all you would need to do then is multiply the top equation by either -5 or -10. And then you could eliminate one of those. And other than that, I think that's all the questions. So I know I kept you 5 minutes over, but I wanted to show you those. And here's all the answers. So this is posted in your module if you want to pull this up, and you can look over. There are all the answers to the questions. All right, so you can check your answers. I hope this has been helpful to you. Yeah. I hope that helps some, just to at least set up those problems. Do I need to go back to them? Did I get off of them too quickly? Do I need to go back to those problems? Okay, and so I had talked with a couple of you about staying over after class and looking at the honor lock thing. So if you want to do that, I'm going to try. I don't know how successful I'm going to be going in there and doing this, but I'm going to try to do it.